Hi. Hi, everybody. Please have a seat. I don't know if there are people at the entrance of the room. Don't be shy. Come and sit. We will start right now, not to lose any time, because after we have an important thing, which is the lunch and networking. So I want to make use. So I'm Georges Lobo. I'm program manager at the European Commission in Digit, and I'm currently the team leader of the SEMIC team. Which is take a big part of the organization of the event. And here, I mean, because I'm leading the semantic teams where we have been doing semantic webs for a long time, it's about is it evolution or revolution? I mean, I just use this word because I mean, a couple of years ago, everybody knows ChatGPT came, and people, there was the big buzz. It was the big buzzword, and AI is still a buzzword. But and people were saying, yeah, okay, we don't need anymore these fixed standards, these ontologies, all this thing that AI will resolve. And I think with experience now, I think there is a more things have changed because we saw that LLMs cannot solve everything. They do. They have hallucination. They can increase biases. So and many administration have witnessed that and suffered from that. And as well, I mean, the most important things, because here we're talking about public administration, and public administration, I mean, they need to serve 100% of the citizens. So it says to me that the use of AI must be understood, it must be linked, reused, and trusted mostly. It's something that we need to link to public values, and we need to enforce in a transparent way, that the data are to render, I would say, the AI more deterministic as it is now with only LLMs. And it's important because now we start using AI for policy making, decision making, to calculate social benefits, to use more in a proactive way as well, proactive public service. So it's important that the decision, if we use AI, that the decision remains fair, they remain precise and based on actual facts, and not by some statistical occurrence of word in a sentence. So that's the thing. And now, I mean, this is, we have seen the emergence, and the people who were here at the workshop yesterday, they witnessed that we are now, semantic is coming back in the game to, I mean, reinforce, and with semantic technology, we're able to constrain more the use of LLM. Of course, it's not to banish completely this use, because they are important use, but we have seen presentation, and I hope with the presentation we will have today, they will be inspired. They are made understandable by everybody. And I will now take, so we will have 4 short presentations, and after there will be hopefully a time for questions from the audience, but as well from me for the panel. So I will invite the first speaker, Leyla Khamlichi, sorry. And Leyla is a senior data scientist at UWV. It's an employment agency in the Netherlands. She specializes in deep learning, language models, and graph-based analytics. And she will present the work she has been doing for as CompetentNL. So I invite you to the stage, Leyla. Yeah, okay. And here is yours.
Yes. Welcome, everybody. Thank you for coming. So within the Netherlands, the last couple of years, we are challenging when it comes to labor markets. I think every country has its own way of challenging within understanding what happens within the labor market, especially with skills. And one of the things that we challenge is that the education system really doesn't understand what happens on the labor market, what kind of certain skills, what kind of occupations are changing actually over time, and how can we enrich qualification systems within the education in the Netherlands. So what we actually build is this new skills ontology that is based for the Netherlands, and actually skills are related related to occupations and qualifications. And it's collaborated by the Ministry of Education, Culture and Science and Social Affairs, where we actually have a skills language where that's actually public available and can be used for different purposes. We did it together with CBS, which is Statistics of Netherlands, TNO, which is an institution for technology, UWV, of course, and Beroepsonderwijs Bedrijfsleven, which is a Dutch organization that comes with qualification systems. So why we actually chose graph databases, first and foremost, we wanted to use an open standard, means that everyone can actually enrich the data. And also the way how we want to represent the relationship is that if we want to understand how skills are elevating over the labor market, or also how people changing within skills and occupation, it's better to represent the relationship in a graph rather than a relational database. So within that is that we built this ontology where actually two organizations came together and understand actually, okay, this word needs to cover a part of the occupation, but also the education system itself. So within that, we could build this ontology, and from there on, me as a data scientist wanted to understand how can we actually use the world of graph databases in a way where we can make different calculations and also inspire policy leaders when it comes to labor markets. So within the project, we actually work with two different frameworks. So we have Research Description Framework, which is RDF. That's actually been used for linked open data and semantics, where actually the two domain knowledge or experts came together of understanding how they have to build a structure within the semantics. And for label property graph, we used Neo4j, and that's we did that actually because it's more accessible in a way, and because we have the relationship have some properties. It can, for me, it's very interesting to see like how I can calculate paths over time to see how I can advise or inspire different job seekers to see what their skill set can go from one to the other one. So with semantic modeling, actually what we could understand is that we put actually labor market data in a way of knowledge where we can actually recognize that skills are explicit and personalized by certain paths. And especially when it comes to when people change their job by moving to the by moving of technology or for other certain reasons, we could actually understand why are people changing and how are people changing. And in that fact, actually, with over time, I came with a research question that I have is when do we talk actually about a skills gap? And what a skills gap actually is that we as data scientists, but also policymaker, are extremely interested in the mismatch between the demand skills and the available skills within the labor market. And because CompetentNL is actually modeled in a way how jobs and learning are related to one another, we can actually understand why skills are definitely missing, but at the same time also how people or how employers actually look to different talents. To give you a better example, so we have two occupations, and in the circle in the green, those are the transferable skills. That means those skills are actually are related to in both two occupations. And if you want to go from the left, let me say the left occupation to the other one, you can do that, but 80% is that your skills are shared, but you're just missing two skills, and the skills gap is done then those two. And then the bigger question actually is what kind of certificates or what kind of courses you can actually you can do so that you can make your skills gap a little bit smaller. But within that, the ontology and also the semantics that we have, we can actually understand then a little bit better how actually occupations are overlated with one another. To give you another example, so this is like a graph that is made, and in this graph actually I try to calculate a path for someone who is trying to come from a certain occupation and wants to see like, okay, where are my skills, where actually are my skills transferable, but at the same time also what kind of skills I'm missing if I want to go to another occupation. And if you put the graph actually back and actually put it in a way as like to say you are a store manager, and then you are interested in to be like a precision instrument making, you see that you just have 50% of your skills are actually shared. So that means that the gap is a little bit bigger. So in this way, you can actually help job seekers, but also employers understand like, okay, this is the skills that you're using or you're actually trying to find within the labor markets. And those skills are findable within those kinds of occupations so that you inspire the job seeker, but also the employer of how your skills are actually combined within other occupations, but also actually try to understand like how people are moving from one part to the other part. And I think what the nice thing is within CompetentNL is that with semantics, it can help us in a way to calculate differences between occupations. So make it like a conclusion for us is that we use Triply for linked open data and semantics, and we use definitely Neo4j for calculation and visualization. But the main thing is that CompetentNL is just like a data set that is based on a very structured ontology. And we use two different techniques of graph databases where we combine together for one to be an open data set. And actually the other one is very interested if we want to understand certain policy questions, where as a researcher, I can actually help them to understand like how we can write actually different policies when it comes to labor markets. Are there any questions? Yes, there are a couple in the room.
Thank you, Leyla. Are there any questions? Can we have a mic here, please? Yeah, here here first.
Thank you for the presentation.
Yes.
Niels van der Kerris from Red Pencil. I was involved quite some time ago with the ESCO ontology, which is the European ontology for skills, competences, etc. Did you consider the ontology, and how does it compare to your work?
Yes. So I think that the major challenge that we had, because of course one of the things that we have to do as well in our data set is that we map our skills also through ESCO in the future. But I think that what the bigger challenge with ESCO is, it's very it's very detailed or very high over, and it's not really written for the Dutch labor market. So that's one of the challenges that we saw over time in 2015, I think. And also the part of the education part that ESCO doesn't have a combination when it comes to linked in a way to an education system. So you can tell them like, okay, those kinds of skills are coming for the those skills will be imported in the future, or you have to change your education system. So I think that's also one of the different within ESCO. And we see that if you use CompetentNL, it's more based on Dutch labor markets, which for us is a little bit more understandable how skills are reflecting and how people are changing, and how you can inspire employers to look different to talent, because the main core of CompetentNL basically is just a data set, and me as a data scientist try to understand like what kind of questions you can actually ask so you can inspire people within skills to look broader than only the occupation, only the sector. Because the most interesting thing is like, if you want to come from healthcare and you want to work in IT, is that possible, yes or no, based on the skills that you have, and what kind of skills are more important for you in the future, so you can learn new skills. Especially what companies a lot of have in the Netherlands, I think everywhere, not only in the Netherlands, is that they find it very difficult to keep their talent within the organization, and they want to see like, can we use certain skills so we can calculate a certain path for the upcoming 10 years, and then you can challenge them, like I say, okay, in the upcoming 5 years, so this is the path for 5 years, and in the upcoming 5 years you should do this occupation to stay within the organization, keep talent inside. So
okay,
yeah,
thank you.
Yes.
Are there we can take another question, short one. There was someone else? No?
I think there
was someone here. Okay.
There.
If you can please be short, so we.
Yes, but I was about to raise the same question because I worked with the ESCO thesaurus also, but from the perspective of the French labor market, which has its own codes and its own ontologies and classifications, NAV codes, etc.
Yeah.
you really shouldn't underestimate the benefit that would happen if to align CompetentNL with ESCO. And also, we're talking about AI, but true insights can also be generated by aligning these kind of ontologies with numbers and statistics from the labor market, seeing which industrial sectors recruit, so they can not only provide what you're providing today, but also say, okay, in what sectors are skills being sought after, so they can inform people looking for jobs to say, this is the direction you should go to. This would help you to really generate insight, cross-reference information. That is also a true benefit. And because we're in a European context, so any alignment with a higher level ontology that may help to map to other member states would be highly beneficial.
Yes, for sure. But that's also where we going to map CompetentNL within ESCO. But like I said, maybe I'm going to repeat the answer, is that it's more orientated to the Dutch labor market, but especially with the education part that doesn't understand how the labor market is working and challenging, like, how can I make a better qualification structure or education system that the students are more prepared for the labor market, because we did also a research on students that they have teachers, and that they say certain skills are not really well covered within the education. So it should be more attending on that part as well. So I just think that whatever the ontology you're using, you try to understand the way how everything works in the labor market. But besides of that, I think that skills is just a part of the puzzle. It's not going to solve everything. It's just a part that helps us understanding different patterns. But still, I think still, if we want to have a skill-driven labor market, it's also the employer that needs to change. Like, look to different to talent and have that conversation. I think that every ontology can make that work in a way. It's just the one that you use, is it more reflected on the market where you're staying in.
Okay, thank you.
Yes.
Leyla, I invite you to sit on one of the chairs here, and we will continue. Thank you. Applause. Now I would like to invite Dennis Diefenbach. So Dennis is CEO of the QA company. He specializes in RDF and semantic technology and applying to real case, and he works for the Commission for DG such as DG Regio and DG Com, and he specializes in researcher in question answering over knowledge graphs. The floor is yours. Can we switch to HDMI?
Thank you very much for the introduction. Let me give a second. Okay. Yes. Should be ready to go. Okay, thank you very much for the introduction. Hello, everyone. I'm Dennis Diefenbach, the QA company. We are a company specialized to solve problems at the interaction between large language models and data. So it can be RDF data, semantic data, but also not. And so the question is semantic and AI, evolution or revolution? So yeah, let's see what I can answer to this. I would say that the answer is that we are something in between. We are, of course, in an evolution, but not completely revolution. And let me try to justify it. So semantic web technologies, maybe just to have a framework, what are they good at? So basically for us, semantic web technologies are ideal when we are dealing with structured data or semi-structured data, when we have a flexible schema, so we cannot encode them in a relational database. And they are especially good for interoperability and for multilingual data. So if we have use cases like this, then semantic web technologies are ideal. On the other hand, we have language models. So this is what mostly people refer to as AI. And language models are good at what? They are good at understanding and generating language. So for me, these two technologies are very transversal. So it's not a revolution in the sense that one will replace the other, because we cannot encode with language models structured data. And on the other hand, we cannot replace language models with semantic web technologies. So there is not a complete revolution here, but we are rather at an intersection of these two technologies where both technologies can profit from each other. So in this sense, I would say we are at an evolution step. But this evolution is quite a step forward because language models became more powerful. So in this sense, we are also to solve tasks that before we couldn't do. So let's go back. Let's say we have a knowledge graph and we would like to use language models for it. And for me, there are two phases. There is basically the construction phase and there is the consumption phase. So in the construction phase, basically, we would like to construct a knowledge graph with the use of language models. And there are different ways to do this. For example, we can use language models for ontology designing. We can use language models for data transformation, or we can use, for example, language model to extract RDF data from text. In this talk, I'm not going to speak about this part because I'm not a particular expert in it, but I would like to focus rather on the second part, which is you have an existing knowledge graph and you would basically like to take advantage of it with the use of large language models. And I will present 3 tasks to do this very concretely so that we can see the advantage of language models and semantic web data. First of all, to have a common example to start with, we need a knowledge graph. So the knowledge graph that we are starting here is the EU knowledge graph. The EU knowledge graph is a public knowledge graph. It is hosted at linked-opendata.eu. It is hosted using a wiki base. And it contains around 1 billion nodes, so it's a relatively big graph. It contains information about institutions of the European Union, countries, capitals, ministries from the Commission, and mostly it contains projects financed by the EU and beneficiaries of the EU. It's a typical example of interoperable data because basically it aggregates data that was aggregated across the member states and unified in a data model. It's a graph like we would expect. So if we click on DG Connect, we will get the different information about the Directorate General for Communication, how it is called in different languages. It's a subclass of the European Commission, and the Director Manager is Roberto Viola. So let's say we have this graph. Now we have language models. What can we do with language models that we cannot do with the graph alone? And the answer is we can do these 3 tasks. So we can, for example, do these 3 tasks. And the first task is linking. So it's a very common task that exists since a long time in the framework of linked data. You have 2 knowledge graphs. You have terms in one. You have terms in the second. And you want to basically find the correspondence. And you can do this with string matching. This would be the old way, but language models are very good at understanding language, at bridging semantics. So you can basically use language models to make this linking. And this is something that we are currently doing. Here it's a set of vocabulary from the publication office. It's 133 vocabularies. And basically what we do is we want to make a connection between these vocabularies and the EU knowledge graph. Here's one example. So we have, for example, the term class struggle or drug addiction in one of these vocabularies. And then we find correspondence entities like class struggle, a concept in political and social science, which is the correct one, but also a film, an episode, and so on. So basically here, the language model helps us to disambiguate between the terms and to make basically a mapping between the terms. So overall, this is a very good evolution step where language models, and here we need small language models. We do not need necessarily particularly big language models, where they can help us basically take advantage of existing knowledge graphs. The second one is about entity linking. It's also a relatively standard task, but which was boosted with language models. Basically, you have a textual representation like this, and you would like to find in this text entities that are appearing in your knowledge graph. And basically here we find the different entities, we mark them, and we make a link to the corresponding entity in the graph. And this can be used across many tasks. Imagine you have a knowledge graph about legislation, and you would like to find entities in the legislation, so you can use this technology. And the nice thing is that entity linking was existing for a long time as a task, but with language models, they become much more powerful, they are more precise, and also what you can do is you take a knowledge graph, you plug it in, and you get basically an entity linking system without doing a lot of work. So you get it basically for free. So also this is a big evolution or nearly a revolution for the field of semantics, in my opinion. The last example is text to Sparkle. So basically, you have a knowledge graph, you would like to access it. Generally, we access it with Sparkle. Sparkle is quite difficult technologies, especially for non-expert users. And so we would like to bridge this gap. Yeah, this is the same graph as I was presenting before, the EU knowledge graph, who is the Director General of DG Connect. And basically, we can now generate from this natural language query the Sparkle query itself using a language model without basically doing it ourselves. Or something like, give me the number of projects in Malta by fund. Yes. What is happening here, the language model is saying cohesion projects are represented by this entity, projects are connecting to funds via the property, Malta is represented by the entity, and at the end, we have basically this fully generated Sparkle query in very few time that we can run if the Bureau token was not expired. Old session. Which we can run and basically get the result. Or we can even go slightly further and say, give me all projects in Malta by the number of funds together with their RDFS label in English. Okay, we try it. If it doesn't work, it's not. And basically, we have the same query before with, here he understood with the, this is the RDFS label of the project. Here he grouped by label, that's a bit strange. Maybe we can refine it like this. Yes, and here we have the Sparkle query that we were expecting. So overall, I hope I could convince you that knowledge graphs and large language models are two technologies which are orthogonal, that one can help the other, that language models can help us evolve in the field of semantics. And I have shown this using 3 concrete tasks that you can use today to exploit basically existing knowledge graphs. Thank you very much.
Thanks, Dennis. Thanks, Dennis. We have time for one question, probably one over there. Can you hand on the left?
Thank you for the presentation. Any thoughts on how you could make your knowledge graph LLM ready? In Vienna, at the Semantics conference, some papers were presented about misleading predicates, human-readable identifiers, and stuff like that, because the language model will explore the knowledge graph the same way as a human would do. So, any thoughts on how to make your knowledge graph perform better with a language model?
Yeah, my answer would be that if the knowledge graph is not AI ready or language model ready, it is also not human ready, so it is not a good knowledge graph. So a knowledge graph to be understandable by a language model must be understandable by a human, and if it is understandable by a human, it will most likely also be understandable by a language model. So I would say you need to work more on your knowledge graph quality. And yeah, there is no magic recipe, but in general, RDFS labels, they help a lot, also for humans to understand it, to have a clear structure. Generally, when you create applications on top, then you see the quality of the knowledge graph. And yeah, so I think there is not a big shift with AI with respect to the quality of knowledge graphs.
Would you say that Wikipedia is a non-human ready knowledge graph?
Wikipedia, you mean Wikidata?
Yeah. Wikidata, sorry.
Wikidata is a very good knowledge graph that humans can consume. And language models are also very good at consuming Wikidata. So it is rather good to construct, for example, Sparkle queries on top of Wikidata. But the same problems that humans encounter, for example, the schema is not always homogeneous. And so you might get different results depending on which properties you use. And the same problem a language model will have. So in this sense, there is no change. The language model is, the knowledge graph is as good for human as it is for language models. Thank you.
Thank you. So I invited you to go to sit. And I'm calling now the next speaker. So I'm calling here Stephen Alstrup. Stephen or Stephen? You choose. So Stephen Alstrup is a professor of algorithms at University of Copenhagen. He has decades of experience in computer science and AI. He co-founded several technologies company and serving the Danish Ministry of Taxation and IT Supervisory Board and advising ministers, organization, basically the government. So the floor is yours, and you have here the click. Thank you. You have 10 minutes.
And I have the time here. Fantastic. Cool. Thanks a lot for being here, and thanks for the invitation. Should I use this one? Okay. Here we go. This is fine. No. Okay. Thanks a lot for the invitation, and thanks a lot for being here. I've been working with algorithms and AI for decades, and one of my company actually had 500 million installation worldwide. So I've also been seeing a lot of practical stuff and implication in how to use it. I was more or less giving this agenda. Stephen, can you talk about generative AI, what's good for and not good for, and how to combine with multiple other kind of AIs, and when do AI succeed and fails, and can you do it in 10 minutes? You're allowed to laugh. But I will try to do my best. And I will try to go slow, even it seems speedy. So, first of all, what is generative AI good for? I mean, I use ChatGPT myself all the time. It's a fantastic tool. I like this kind of tools here. It's good for summarizing a lot of text, good for rewriting, good for ideas and creativity, and so on. I mean, you all know probably, and very happy about using this kind of tools in your daily life. Me too. In addition, ChatGPT is very friendly. I'm always brilliant, I'm always smart, I'm always right. I can suggest that I should fire people in my company, and it's a brilliant idea. I can also suggest we hire more people, and that's a brilliant idea. And I can just go into the left or go to the right. I'm always right, and always get supporting information for my brilliant ideas. That's nice, right? I feel good. So what is this last language not good for? Telling the truth. Actually a little bad after being telling you are so good. And then realizing that it's not telling the truth all the time, right? Then also we have the problem with logical reasoning and complex solving. I mean, try to feed it in with simple information about a company or a loan you have, and then try how would that develop and so on. I mean, you just get misinformation for sure. Yeah, more or less. Yeah, structured outputs, try to put some barriers around and say that, hey, it's always like that the balls are only blue and never yellow or something. I mean, it won't respect it, right? It won't follow the rules. Boston Consulting, I don't have any shares, so I'm allowed to show it here. They made an excellent little test some years ago with the people, giving a tool and not giving the tool. And then they were saying, use ChatGPT or something I like to make some creative stuff. I mean, what is good at? and they could see like a 40% increase in efficiency, quality, and so on for the employees. They also gave the tasks saying use these tools for, doing all the things it's not good at, like this complex resonating logic and so on. And they could see a decrease in efficiency with 23%. Why? Because people was actually believing what the bot was telling them. Without the bot, they would have been doing the right thing because they were using the brain themselves. But with the bot, they failed. It could be super nice when we're using generative AI if we had something like a confidence score. How sure are you about what you are saying? That would be super nice. Now it's just always 100% sure. This is right. But we don't, and we will never get, in my opinion. With all other kind of AI, or most other kind of AI, we actually have a confidence score. And you know it very well, like for the forecast, it's going to snow in the weekend, and there's 80% chance for it. Or we're looking at a picture, and this is a picture of a banana, and it's with 90% chance it is a banana. And we're used for this kind of communication, human beings also. Like, if you ask me a question, I'm tell you some information, but I also tell you, I'm very sure, I'm not that sure, and so on. And you combine that together here. This is what we're doing all the time. And this is also the problem with pure generative AI, that it kind of communicates 100% sure about something that is really wrong. But then you believe it's sure, and then you see all the mistakes. But we can combine the stuff. So, for example, if we get an email in from a citizen, we could use old-fashioned classification AI to say, what is this text about? We can also find maybe the right suggestion for what you normally tell a citizen giving this kind of question here. And then we can, in the end, maybe use generative AI to dwarf a response, kind of making it more personalized for this specific mail here. So we can combine the stuff. But AI, generative or not, is about statistic. And the world is not statistic all the time. We have fixed rules. Like in Denmark, if you want to have a beer in a bar, you need to be 18 years old. Don't use AI to implement that. We have a simple rule, classic IT. If you're above 18, you get the beer, otherwise you don't. And it's really beautiful, it's easy to test, it's easy to implement, it's easy. So, I'm just saying everything is not AI and shouldn't be AI, but we should combine the stuff together here. Why do AI succeed and fail here? 4 minutes left, thank you. We try. The biggest reason why AI is failing is because we don't have skilled people. And we don't have skilled people in Europe. We have kind of been resisting in training people in IT and AI in general speaking. That's how it is. In Denmark, we have an estimate before DRAG here, the report here, that we needed 300,000 specialized IT people. We only have 70,000. So before we know people knowing something about AI and IT, we will just continue talking about it, right? So we have a lot of visions in Europe, but it will stay vision until we have people who can implement it. This is just how it is, and we will fail. Other reason why we are failing is a typical thing is that we do something, but we don't think about what is it the business objective is. So if we take, for example, if it was a customer control here, then I can hear some people saying, oh, in 99.999% of the cases, when the AI have selected somebody to be controlled, there's some fraud involved, and it is really good. Is it good? Is it the business goal, that the AI pick something where there's fraud all the time? Or is the business goal that we actually, catch the big criminals, right? That's the question. So, and I see it all the time here, that the business people just have put the brain somewhere and let the tech guy like me just do something. And I don't know anything about the domain here. So maybe I'm doing it totally wrong, what I'm optimizing. It is the business guys who should decide what to optimize and tell me, and then I'm implementing it. If you don't tell me what to do, it's probably someone being 25 years old, just dropping out of university, making that decision for you. And should it be like that? No, it shouldn't, right? EU legislation is a big, big problem. In Denmark, this city here, we made an AI algorithm to, if you were sick and coming home from the hospital, we had some AI to control if you have got all the things you needed. It was not allowed to suggest to take something away from you, but only tell what you need more than what you have been given. We couldn't put it in production because of EU legislation, right? 1 minute left. So, one key message: when you make automation, you remove people and introduce IT. That means that there's tons of decisions which will be made by management. Things you didn't do before because you have real people doing it. But if you don't make the decisions, then it will suddenly be, the IT people doing it, and we don't know anything about anything. Last thing I want to give you: when other people are watching Netflix, I have a little game I'm playing together with ChatGPT, and it's going as follows. I say, I have 4 rabbits, each have 2 kids. How many rabbits do I have in total? And the answer is, I have between 6 and 12 rabbits here, depending on how they've been interacting with each other here. And ChatGPT is responding, oh, you have blah, blah rabbits. And I say, no. And then I have to tell it like, hey, you need 1 kid have 2 parents. And I was trying to tell it rules, right? Strict rules, follow these strict rules, but it won't. And it suggests, 100 rabbits, 2 rabbits, and all kind of things. Try yourself. I cannot make it by the rules here. And this is just simple telling us in a simple way here, we need to combine. We need to combine the different kind of AIs, but also with strict information and rules here. Otherwise, it will not work.
Thank you, Stephen. An applause for Stephen, please. Yeah. So let's take a chair. And I will call our last speaker for today before the panel. So Ed Curry. So Ed Curry is a professor of data science at the Insight Research Center at University of Galway, specialized in semantic technology, data management, event processing. And give you the floor. Please.
Thanks, George. So today I'm going to talk to you. I suppose is it a revolution or evolution? I think my answer is the same as maybe some of the previous ones. It's a bit of both. And we actually have the wrong set of slides, but that's okay. So what I want to talk about is AI to start off with. So this is a report from McKinsey that goes back over the summer, where they looked at 2,000 different executives inside different organizations. And what the question was is, are you seeing any value from your AI solutions? Have you deployed them? Well, the first thing is, out of those 2,000 people interviewed, 80% of them had actually deployed AI in at least one business function, which I thought was quite high. Mostly they're in the early stages of pilots, and they're, scaling hasn't really happened yet. They were seeing benefits in the area of innovation, employee satisfaction, customer satisfaction. But if you look at the numbers here, what you see is that the vast majority of organizations are not seeing benefits yet. So there's a clear disconnect between what AI can do and the value that it's delivering. From the point of view of data, there's a clear challenge with data. Our semantics are getting more complex. We're working with radically different types of data, different types of use cases, and this is a lot to do with the ever-increasing rates at which we create data within our society and the challenges that we have with them. We used to have very simple structures of data that used to fit in tables. 20 years ago, that's what we used to teach students. Today, the challenge is that we have digital twins of the earth, of the human, and we're now looking at hundreds of thousands to millions of potential attributes on our data types. Fundamentally, semantics are very challenging. We have multiple perspectives in the world. We have ambiguities, we have vagueness, we have consistencies. We have two people from two different disciplines that can come up with different conceptualizations, valid conceptualizations of the world. And that is something that's very, very difficult to challenge. If humans can't agree on the differences, how can we expect AI to agree on the differences? And this is a fundamental thing that we have to face in the area of semantics. When we start looking at the types of data that we have, it's not all factual. It's not all objective facts, objective data that we can look at. In fact, a lot of our data is subjective. It's opinion. And its subjectiveness goes down to that individual, to the person. If we look at, for example, hotel reviews, if I ask a question, I'd like to have a reasonably priced hotel in Copenhagen. Well, a reasonably priced hotel for a professor is different than a reasonably priced hotel for a student, which is different to a reasonably priced hotel for a CEO of a big company. So working with the different types of subjectivity, it's very personal how it's represented, it's very personal how it's queried. Touching on Francesca's keynote this morning, she presented a brilliant vision for Europe. But if we dive down to the data part and to the AI part specifically, I think the Commission have done a great job on putting forward a proposition where we have data spaces, where we have high quality data that can be used for training, that has a community of users and owners, that we can actually have clear data governance frameworks in place to train our AI systems. This is incredibly valuable and doesn't exist anywhere else in the world. So there's a real strong vision there. At the same time, we now have AI which can actually help us to extract value from that data that we have. So there's a clear opportunity in front of us here. However, it's really important, and particularly for this community, to understand the importance of data there. When you look at that AI value chain, whether it's an AI model or an agentic system, fundamentally, it's based on a model that is fundamentally based on data. If you go back to that survey from McKinsey over the summer, they asked the executives, the business leaders that they interviewed, what are the challenges that you're having? Why can't you scale your AI pilots? And the answer that came back was, well, we're worried about the data. We're worried about the data quality. We're worried about the data governance with it. So a key barrier to scaling to scaling AI was challenges around data. So if the business leaders don't trust their company's data, how can we expect an AI or an AI agent to autonomously make decisions using the same data? So there's a clear challenge here around trustworthiness, around data governance, and again, something very important for this community. In the area of looking at AI for data and supporting data, the Data Spaces Support Center has done a really excellent white paper that looked at the opportunity across the generative AI value chain to understand what are those opportunities that exist with LLMs and Gen AI for data. They came up with a lot of recommendations. I highly recommend them. But the opportunity is there. Dennis talked about how you can use AI to consume and to work with knowledge graphs, but you can use it to build it as well. This is a collaboration that we did with Fraunhofer last year. Very quickly, we gave an instruction to ChatGPT to say, hey, with this data shape, can you create some a shackle shape for it? It came back with an answer. You know, that answer was pretty good. It wasn't perfect. It required some human intervention to fix a few things, but it was pretty decent. The BDVA community and working with SEMIC have investigated the opportunity for large language models to support interoperability. And they found a number of cases of where this is possible. So there's real opportunity here. There's a real goal for us to be able to go for. I think some of the key challenges that exist here, though, are potentially of interest to this community. The first thing is we need to stop thinking about AI and data life cycles as being independent. Fundamentally, we need to look at a unified life cycle between how we create data, how we manage that data, and then how we put that data to use in training models, and then how we use those models to solve specific real-world problems. We need to look end-to-end. We need to look at a unified life cycle. And this is a very simple example of looking at a life cycle of a data space and attaching that to the life cycle of an AI model and how it's used. This is where the symbiotic relationship comes together, and this is where the opportunity exists. In terms of evolution, the BDVA have been working at the idea of AI-ready data products. So a data product is a very interesting concept. It's existed in consultancy for a long time, but it's about looking at a piece of data that I want to be able to exchange that solves a particular value for a user. Looking at AI readiness around that delves into what are the key challenges that we have to make data AI ready. And when we share a data product, that data product can be used and put into models straight away. What's interesting here and what wouldn't be news to this community is that when you look at the things that are needed to make a data product AI ready, it's things like data quality, data provenance, lineage, licensing, all things that the SEMIC community have been working on for a number of years, which highlights the importance of what we do here in this community and how it can enable AI-ready systems using the data that we create. There's a need for this end-to-end standardization of data governance. So looking at things like DCAT and the evolutions to ML, DCAT, AP, what else do we need to make end-to-end governance possible across this unified lifecycle? And there's been a lot of great work in SEMIC, and I believe there's future work that's needed there as well. Finally, I'm a professor, so I always think about what are the research challenges with this? What are the next research projects that we'll get involved in? And I think there's real opportunity here to understand how LLMs and foundation models can help us to scale the challenge that we have in semantics. How do we leverage LLMs to be able to tackle that long tail of semantics that exists within all of our data systems? Do LLMs give us a new way of kind of rethinking what the knowledge paradigm is? So obviously, you know, consensus-driven ontologies are the gold standard. That's what we all want. But the vast majority of our data sits outside of that. Can we leverage these models to be able to help us do good enough approaches to interrogating and working with that data? What does data quality mean in this world? What does data quality mean when you've got subjective opinions in your data set? Is my data quality different to your data quality because of the opinions I hold and the opinions you hold? These are interesting questions to explore, interesting things to be able to understand. And then finally, how do you test these systems? When you have this variability, this approximation, this good enough approach, what does testing look like? How do you build trustworthy, reliable systems? And I think those are interesting questions for us to further continue to explore. And George, with that, I will pass back to you. And I believe I'm even on time.
Thank you. Head. You can keep the mic. So we still have, you've been short, so we still have 1 minute for question. And maybe if you have also for Professor Alstrup, let us know. Are there some questions? No one? Ah, yes, one. Mm-hmm. Yeah, it's coming.
So thank you. I'm Jon Lund of the Danish Tax Agency. Mm-hmm. I'm wondering, to me it seems the promise of AI is building itself, abstracting ontologies from data sets that we don't really need, in theory wouldn't need any human beings to build them, but the AI itself should deduct and abstract those meanings and semantics from the data set we give it. So that promise, how do you see that? Is that a fantasy? Are we getting somewhere near that, or yeah? How's that to you?
So I think that's that really is that open research question that we have. I think something like that is possible, particularly when you start looking at, you know, there's different types of embeddings where people look at grounding semantics. But the challenge here is it's the human problem. If we all try to actually agree on things in the room, we do find that we have different perspectives of the world. And that's a fundamental problem that we can't get away from. If humans can't agree on the semantics of something, we can't expect AI to agree on it. If we can agree, I think AI can definitely show us where that consensus possibly exists. But it won't be a silver bullet to solve all interoperability problems, because fundamentally the humans will need to have that common understanding, that shared meaning between each other. But the reality is that we're probably never going to get there where we all have it's a human problem. We're never going to have that shared conceptualization. So can AI then help us to mediate that, to at least explain the differences? How are you perceiving the world different to somebody else? What are the differences in these data models? So I think it can create a lot of useful tools in that space for us.
Mm-hmm. Thank you.
Thank you. Please have a seat. So I guess we have some minutes left for the panel. So since the other, I was informed just now that the others are late as well, so we may have some time. So I will ask first question. I mean, maybe the last question that was asked, because you, to Professor Curry, Leyla, if you want to comment, because you've been busy building on ontology. So what do you think about the remark was made using AI to build ontology and removing the human?
I think that from our project, where two different organizations came together to agree on semantics, to cover a word on occupation and education, it took a lot of time, a lot of discussions. I think almost 2 years of the project to just build an ontology based on certain words. So as the professor was actually saying that the way how we look towards data, that's maybe I look differently than you, and that makes it, I think, not always easy to build an ontology where you can say that it will help AI to give a better response. I definitely do believe that semantics is an extra layer for an AI to understand that there is a relationship between words that makes it from a mathematical perspective easier. But I think still that it's very important to have this human interaction of what is an ontology and what is actually the semantics between words. So if for me personally, I definitely think that semantics and AI is not a separate world, but it's something that you can combine. Depends on the business case that you have, because sometimes you cannot solve it even with semantics. Within the government, we have to deal with a lot of historic data, and trust me, that's not even easy just in one organization come together with different departments. So sometimes even semantics cannot even solve that, and that's also something you need to be okay with. So again, I think that semantics can definitely help. But as the professor is saying, like, it's in a way it's difficult sometimes to get a good ontology based on what we mean with certain things. So that's the way I would think about it.
Thank you. I don't know if Dennis or Stephen, you want to react on that? Or, I mean,
yeah, maybe very shortly. I mean, I agree. And the problem is that basically ontology itself is a tool to basically you have two people and you want to agree on something. And to agree on something, basically you have to change it inside here. And the ontology is a way to conceptualize this change. So we bucketize things in the world. The ontology is used for that. Is this the same thing? Do we need two concepts? And so, okay, AI can now help us to make emerge one thing, but this will not change what is in the head of the people. So you have also to do this exercise. So it will not, the AI will not give us back an ontology and this will be perfect for everyone. No, it doesn't work like this.
Thank you. No reaction, no. Maybe I will ask now, Stephen, a question because you addressed it. I mean, about the missing skills in, I would say, in the public sectors. And this is, I mean, something that touched me because, for example, in SEMIC, I mean, when we built our semantic asset, it's not that we are in a corner, the IT people, it's a community. So, and as we say, I mean, because we play a sort of consulting role also for different domains. The message that we say, I mean, it's not that they ask us, yeah, can you build an ontology, I don't know, for the justice or for things, and I say, yeah, but you need to bring the expert because we are not expert in our field. So we need to have the business people to tell us also how to modelize, and as you say, I mean, to come to an agreement. And how do you think, I mean, how we could cover this, I mean, this message, because I think is what you were trying to see. I mean, as you've been also experiencing some success in that, things to pass the message that, I mean, you cannot let IT do his work alone or without the business, or?
Yeah, I'm sorry. I'm sorry. I'm just. It's a good question, but it's. I'm kind of shocked. Like what I'm seeing, business people just like just letting IT people decide what to optimize, not optimize. I mean, it's. We don't have any skills, any knowledge about it here, and I really don't understand why it is like that. And maybe it's because it's kind of the overestimating what AI and IT can do. I mean, you just figured out what to optimize. I mean, this is. to solve the problem, I think there's only one way here, and that is to place people with skilled IT skills in the very high management level here. Otherwise, the world have been digitalized. So we need this kind of understanding of digitalization on the top management. If we don't have it, it will just continue being like in the old world, the way of thinking. I was sitting with one of the CFO for one of the biggest company we have in Denmark, and the person was telling me came home from US and saying, Stephen, I was driving and my GPS was not working, so I used Google Maps. Do you know you can use that? And saying, sure. I mean, we're talking, it's a few years ago, 2 years ago. And saying, yes, I know it. And then the person was telling me, Stephen, it is like, I mean, it seems like, it picked a route where there's less traffic, but that cannot be true, right? And I'm just saying, this is top management, what I meet here. And it is for IT people like you and me, I mean, it's kind of, wow. Wow. But you have to realize that being 50 years old here, or something like that, and sitting in the top management, all this is really something you have not been born with, and it's new here, and don't understand. And there's only one. Sorry for the long answer here.
No.
I mean,
okay.
There's only one. It's not a 2 hours lesson and conference. It's kind of it's hard skills. You're not born with it. We need IT people in the top management. Otherwise, it's not changing.
Okay. And then a few others, yeah.
I'm just going to react to that. I think you're right to a point, but actually, what I think we need is not I definitely need engineers and technical people at the top. Absolutely, I agree with that. But I think that the transformation that we need is general literacy of the technologies. And what we need is our business people, our business leaders, to be more aware of the potential of the technologies and what they can do and also what they can't do. So data savvy, AI savvy business leaders, because the competitive advantage comes from understanding your business. It comes from understanding like Siemens, do certain things better than any other company in the world. And a Microsoft or an OpenAI or a Google is not going to tell Siemens how to run their business better than Siemens. But it's getting Siemens to understand how can I run Siemens better using AI and using data, which they're actually pretty good at. But I think that's the challenge that we need to have.
Very short, I agree with you. We should do that. But to make a big difference, we need the IT people in the top management. And if you look at the top companies around the world, it is started and it's run mostly by IT people. Yeah, this is how it is.
Thank you. Dennis, Leyla, you want to? No. I mean, Dennis, maybe.
Okay, so maybe the relationship between IT people and business is quite complex. And in fact, these things make projects either fail or work. And the goal of the IT people is to understand the business problem. If they don't understand the business problem, they can construct whatever, it will never work. And the goal of the business people in such projects is to also understand. Because honestly, if you do not understand what the IT people are doing, then it also will not work. Because you need to find a common agreement. And how to scale this, I don't know. But for example, if you say, I put 2 million on the table and now we make an IT project, no, that's the wrong approach. Put 3 people, make a small proof of concept, and then scale. If it works, scale it out. I don't have the perfect recipe, but yeah, I feel it too. So it's very difficult relationship, and it's crucial to make things work. But I would say both have to understand each other, and if you have the feeling that you do not, then it will not work out.
Thank you, Dennis.
Yeah, I think the only thing that I can add from as a data scientist is that I'm coming in that the data is already there and I need to do some magic as a wizard, like, hey, here's data, and try to fix a model or try to do something. And then most of the time is that I have to deal with quality of data that is not really enough for certain models. I think for machine learning in general, yeah, you can deal with it, but when it becomes, especially when the deep learning models becomes more a black box, then it becomes more challenging. And I do agree that you need to work together with the business and some from an IT perspective to come together. And I think what we did in CompetentNL very much, because in the beginning it was also that I was telling the way how we set up the project. But I think it's very important also to take it from a domain expert, that person also telling, but yeah, but what is the bigger version? What do we want to actually reach, what we do want to reach out to with CompetentNL? We want to make a data set and not a data set so that you can make certain data science model. No, we want to make a data set because we want to understand the labor markets. So working together and compromising in that, it's very important. But as a data scientist, you should also put a lot of work and effort in understanding the business so that you can understand the outcome of your models. Because most of the data scientists, what they do, like, I have an outcome, yeah, but I don't know how and why. And that's something that's also an attitude that needs to be changed. And I think that when it comes to quality of data, is that a lot of businesses, I can only speak for government, is that there is a lot of historic data, and not everyone understand very good the processes behind collecting the data and to make a right data model. And then after years, there's this AI coming up, and everyone wants to, you know, do with some of AI and tell like, hey, we do something with AI. And then they actually recognize like, okay, actually, we as government or we as organization, we cannot do certain models because we don't have the right data set and we don't have the right quality of data. And that goes back to, but how do you collect your data, and what is the data management in that? That's where it all started. So I do agree with everyone saying that in the top level, there should be more people that have experience when it comes to IT. But at the same time, what he was saying is that they should also collaborate and come together and understand the world together. Like, this is the way how I see it, and this is the way how I see it. How we can compromise to make it work and see it from a bigger perspective. So one thing that I can add.
Can I just ask a follow-up? When you mention data quality, is it for the analysis you make? I mean, to produce what you make, or the data that you use to train your AI system?
I don't think I understand your question.
No, I mean, you can use data. I mean, to train specifically.
Yeah.
Data, and there, I mean, this is what also the SSC has been working on, this AI data ready, and the question have been, if we train an AI system, an LLM with scrap data, you will get scrap out of it.
Yeah.
Or do you mention that to use your LLM to analyze the data, so you don't train it, but you use it to analyze? I think is what you do. You produce or you train your large language model with the data from the employment agency.
So I think like I'm just not speaking about only large language models. I was just speaking about a machine learning perspective. Okay. So that's more in like collected in relation databases. The quality of data is, of course, it's important because it's garbage in, garbage out. And if you want to train your model to understand certain patterns, then yeah, you should have a good quality of data. But what is good quality of data? What is that in what kind of model? What kind of features? It's a bigger question than just say the quality of data is not enough. Is it enough? But how do I know that the quality of data is enough to collect to train a certain model? Is it not that I don't have enough features or not enough information, or do I don't understand? So I think it's a more bigger thing than just to say easy like the quality of data is not enough. I think it's a more hypothetical question. As a data scientist, you should be asked like, but why is the model producing certain things, and what can I solve it? And you cannot change easy the quality of data. It takes it's a process of time. So that's what I mean with it.
Stephen, you wanted to react as well. Sorry, I interrupted you.
I just want to sum up saying it seems like we agree that one key thing is that we have people with different skills being in the same room talking together. And the only thing I'm emphasizing is we also need that on the top level management.
Okay. So thank you. I mean, I guess now it's time. It's almost 1 o'clock. You must be hungry. And if we don't stay, you will become hungry. So I would like a big applause for our speakers. And thanks for this very interesting discussion.